So here's a quick look at the wiring harness for the wing. This is the right wing. Here's the flap servo bay here. And I've got two wires. So we have wire set number 1, which runs to the flap servo. And we're going to be connecting that to a 6-pin MPX or multiplex style plug. And we're going to have an automating system. And the other end, the female end, is going to be in the fuselage. This wire here is for the aileron, and that runs from the connector again all the way out to the root, and there's going to be another connection with a 4-pin DIN connector to hook up the aileron servo. The wire I'm using here is from Power Box Systems. This is a very lightweight wire. You want to try to reduce your wire weight wherever possible. Now I could share the power and ground between these two lines here, but this plane is so darn light I really don't need to sweat every single gram of weight. Now if you want to learn how to do wiring harnesses correctly, get my F3X building clinic. I do a complete seminar on how to do wiring harnesses, how to solder correctly, how to add strain relief, what connectors to use, and all that good stuff. So that's a really good resource for you to learn how to do this. So let me show you some other details of the harness. Now for each of the wing servos, I cut the original servo wire length down to save weight, of course, but I also wanted to add a pigtail type disconnect system. Instead of wiring the servos straight to the wing connector, I have a quick disconnect here. This is a competition airplane, and I want to be able to replace the servos in case I strip one or have a failure. I want to be able to pop the servo out of the frame, disconnect it from the pigtail, and drop in a new servo, and that makes it really quick. My other planes have the same kind of servos on here, so if I needed to, I usually keep a spare, but I can just pop a servo out of another airplane and replace it. So that's a quick way to set these up for a quick disconnect. Now here's the pigtail for the aileron servo. This is going to plug into the tip, the aileron servo, power that up and give it the signal, and then it goes into a 4-pin DIN connector on either side of the wing. So this side, the female side goes into the tip, male side goes into the root of the inner panel, and it just plugs in. This will be an auto connect system as well. Now here's a harness that's going to connect the wings to the receiver. I've got these marked here for both flaps, both ailerons. This is set up. I'm not sure where the receiver is going to be yet in the airplane, so I have these set pretty long, and I'll cut these down to size to save a little bit of weight, but just make everything clean in the install here. And then these are going to wire into 2 of the multiplex 6-pin connectors. Now here's a female multiplex connector set into the wing here. Just cut a slot and countersunk it in. I have a template for these connectors, so it makes it pretty easy for me to do this. Now for the Vixen here, you want to make sure that you don't install it up here, because this is where the ballast tube is. You won't be able to run a wire there. So just be aware of that. So I just mounted it in between where the ballast tube is and the rear wing locating pin. I like the multiplex connectors because they're a little bit bigger, the pins are bigger, they're pretty easy to solder and set up, and they're pretty robust for doing connects in and out, and I've had no problems with these. You could use a 4-pin DINs on here, but I just like the bigger size of the multiplex. Now it's totally fine to use a small servo like the 6110 in a large winged airplane like the Vixen, but you really need to use servo frames. And these servo frames are available from SoaringUSA to fit specific MKS servos, and I highly recommend these. You know, one, the frame provides a better mechanical bond of the servo to the wing skin. It makes the servos very easy to remove, but more importantly, it provides a ball bearing support for the output spline and output axle of the servo. Because with being this small and having the large flap surfaces and aileron surfaces here, there's a lot of push and torque on the surface here. Even if you have a ball bearing supported servo, it's going to wear out pretty quickly at this point here. So with the frames and the ball bearing support, it gives you more precise movement of the servo. It's going to put a lot less wear and tear on the servo and make the servo last a lot longer. So let's check out the frame a little bit closer. So here's the raw servo frame, and here's the main feature, this little ball bearing race here. Press fits into one of those slots here, and you pick which side you want depending on how the servo is going to be orientated in the plane. And it's just a press fit into that hole. Now instead of a servo screw to hold the arm onto the servo itself, you get this little machined aluminum piece which just screws right into the same hole here, captures the arm on the servo, and this machine piece plugs in to that ball bearing on the other side of the frame here, like that. So there's the other end here, plugs right in. Now this aluminum piece just runs inside that bearing race here, so as the servo moves, you have full support and low friction support on the other end of the servo here. So even without the screws being in there, this thing is, there's just no play or slop. It's super, super tight. Now a new feature on these frames is this little step right here, and what this allows you to do is to tie the bottom skin to the top skin. Once you glue this to the bottom skin here, you can use a balsa shim glued in to tie bottom skin to the top skin and create a structural box there. Prevents the servo from oil canning on these really thin wing skins from going up and down when it's under load. And once it's tied into that top skin, it just ties everything together, makes everything much stiffer, and it'll make the servo movement much more precise. So here's a look at the unique servo tray for the rudder and elevator servos that plug into the tail boom. It took me a little while to figure this system out, and at first I thought it was a little wonky, but once I got it all assembled, it actually works pretty well and it's pretty lightweight. So this end here slides into the rear tail boom, and there's these two bulkheads here, and there are slots for the push rods coming into the servos here on one side. I did have to modify the tray. This is a pre-production model of this tray here, so I had to do some extra cutouts here to fit these particular servos and get some clearances for the servo arms, but that was no big deal, and I think we'll be modifying this setup in the future here. Let's flip it over. So the servos are basically flush mounted into the servo rail here on one side. Now the tricky part is this fuselage is so narrow, we need clearance for the servo arms. So they're flush mounted on one side, but they stick out on this side, like that. And there's just enough clearance for the arms. They're going to have to be pretty short. So this is elevator up front, rudder in the back here. I use some cap screws here, Allen head cap screws, to really capture this in, so it's nice and stiff here too. You can see for the wiring, I trimmed down the stock wires here because this is going to have to connect into the receiver on the nose end. So I shortened the wires up and I added a 4-pin Dean's connector. Especially if you're going to be unplugging and replugging this plane a lot, I trust these connectors over regular servo connectors, but you can do it either way here. So this will plug into a harness at the front of the airplane and then connect into the 2 channels for rudder elevator. So it's a pretty neat and simple system. Everything has to fit pretty precisely, and you have to watch clearances on your servo arms. I think this one's going to have to be trimmed down just a little bit, but you want your arms short anyway. So let's see how it fits into the fuselage. So you just slide the tray into that tail boom, and it's captured, and there's 2 stops marked on the wood here, and it can't go in any farther. So there's your perfect position right there. Cut and trim the push rods like you would do with any install, and make sure the push rods don't have any flex in them. We'll cut those down to length pretty soon since we have everything centered and ready to go. And here's the wiring connector for the front of the fuse. So it's pretty slick here. Again, you just got to watch for your clearances on your servo arms. You don't have to use the screws either because the arms are captured in the tray here, so they can't come off. Then for transport, just untape it, pull it apart, disconnect the wire, and you have a nice 2-piece fuselage, nice and short.